Problem number 8. We have the limit as x approaches infinity. So this is like problem number 1. We're interested in where the highest exponent is located. We see a cubic here, and that is in fact the highest exponent. So we focus in on their their leading coefficients. We have an unwritten 1 in the numerator, and we certainly have a 4 in the denominator. C is our answer. Hopefully this is starting to be a type of problem that you're getting extremely quickly. With number 9, this time the limit as x approaches 0. So in order to get this, we have to plug in 0. We plug 0 into the numerator, we have 5 times 0 plus 8 times 0. If we plug 0 into the denominator, we have 3 times 0 minus 16 times 0. 0 over 0, that's our indeterminate form, so we need to simplify. So we go back to the numerator. What do 5x to the 4th and 8x squared have in common? They have an x squared, exactly. So pull that x squared out. 5x to the 4th divided by x squared is 5x squared. Plus 8x squared divided by x squared is 8. In our denominator, what do these two terms have in common? Yeah, they also have an x squared. So let's factor that out. 3x to the 4th divided by x squared is 3x squared minus 16x squared divided by x squared is 16. Okay, remember we're still taking the limit as x approaches 0. We don't want to plug 0 in yet because we need to cancel something before we plug in 0, otherwise we're just going to get the exact same result as before. What are we allowed to cancel here? Well, hopefully you said the x squareds. We have an x squared out front and an x squared out front. So they are now isolated from the items in the parentheses. They can eliminate each other. Now when we take the limit as x approaches 0, what happens when we plug 0 into the numerator? We get 0 plus 8. How about 0 in the denominator? 0 minus 16. 8 over negative 16 simplifies to answer A. Problem number 10. For which of the following does the limit as x approaches 4 of the function exist? This is your finger test problem. Okay, here's x equals 4 for Roman numeral 1. As we approach 4 from the left and the right, our fingers would touch. Yes, we have this dot here, but it doesn't matter what's happening at 4. It's what's happening as x gets really, really close to 4. So this limit will exist. So we'll give it a check mark. Let's go to Roman numeral number 2. Again, finger test. As we approach from the left, we're heading to that value. As we approach from the right, we're heading to the exact same value. So the fingers would touch. The limit exists. Roman numeral number 3. As we approach from the left, heading up there. As we approach from the right, heading down there. Fingers are not heading towards each other. They're way off. One's down here, the other's up here. The limit does not exist for that third. We want 1 and 2 only. Finally, number 11. Alright, you should be an old pro at this by now. Limit as n approaches infinity of 3n cubed minus 5n over n cubed minus 2n squared plus 1. N cubed located in both the numerator and the denominator. Leading coefficients, 3 in the numerator, 1 in the denominator. You're done in less than 10 seconds.